lecture number 6. Today we are going to study the characteristics of angle of contact. Characteristics of angle of contact. Here first characteristic, liquids which partially weights the solids. The liquids which partially weight the solids, for those liquids theta is acute. This is our first characteristic. Liquids which partially weight the solids, theta is acute. Now liquids which does not weight the solids, here theta is obtuse. This is our second characteristic. Now third one, liquids which completely weights the solids. Liquids which completely weight the solids, here theta is equal to 0 degree. Theta is acute, means we get concave surface. Theta is obtuse, we get convex surface. And the liquids which completely weight the solid, theta is equal to 0 degree, we get here plane surface. Now fourth one, angle of contact is constant. Angle of contact is constant for given solid liquid pair. Angle of contact is constant for given solid liquid pair. And last one, any small change in the solid liquid surface or pair causes a large change in angle of contact. Small change causes large change in angle of contact. Small change in solid liquid pair causes large change in angle of contact. These are the 5 characteristics of the angle of contact. I will again explain. Liquids which partially weight the solid, theta is acute, we get concave surface. Liquids which does not weight the solids, theta is obtuse, we get convex surface. Liquids which completely weight the solid, theta equal to 0 degree, we get plane surface. Angle of contact is constant for given solid liquid pair. Suppose we consider glass and water, then angle of contact is constant. Suppose if you consider glass and kerosene, again angle of contact changes. Suppose you consider mercury and glass, again angle of contact changes. Suppose you consider plastic and water, angle of contact changes. Suppose you consider there is small change in the contamination, or we consider suppose liquid density or anything. Suppose they add impurity, then small change in the solid liquid it gives large change in angle of contact. These are the 5 characteristics of the angle of contact. Now we will consider next article here. Shape of a liquid drop. Okay, now suppose we consider this is the solid surface. Suppose this is the solid, and on this solid, suppose we consider this is the liquid drop is there. This is the liquid. Okay, this is the liquid. I will write here liquid. This is the liquid and this is the solid. Now suppose we get here suppose this is the angle of contact. I will write here theta. Now we consider here air is here, this is liquid and this is solid. Now we consider three forces of surface tension. Suppose this T1 is the surface tension of liquid solid interface, this liquid and this solid. Now this T2, suppose T2, this is the surface tension of solid air interface, and T3, suppose this is T3, this is the surface tension of liquid air interface. Now for equilibrium position, we will write here, that is T2 is equal to T1 plus T3 cos theta. See here, T2 is equal to T1 plus T3 cos theta. That means if we consider T1 is in this direction and component of T3 in this direction is T3 cos theta. See here, component of T3 in the direction of T1 is T3 cos theta. That means T1 and T3 cos theta, they are in the same direction, which balances T2, and therefore I will write T2 is equal to T1 plus T3 cos theta, and therefore I will write mathematically cos theta is equal to, I will write here T2 minus T1 upon T3. Suppose this is equation number 1. Simple mathematics. T2 cos theta is equal to T2 minus T1 on this side and T3 to the denominator. Cos theta is equal to T2 minus T1 upon T3. Now I will consider number of cases one by one. If T2 greater than T1, if T2 is greater than T1, cos theta is positive, and I will write here theta is acute. If T2 greater than T1, cos theta is positive and theta is acute. If T2 less than T1, cos theta is negative and theta is obtuse. This is second case. That means if T2 greater than T1, cos theta is positive, theta is acute. Secondly, if T2 less than T1, cos theta is negative, theta is obtuse. Now third one, if T2 minus T1 is nearly equal to T3, then cos theta is equal to 1 and theta is equal to 0. This is the third case. And fourth case, if T2 minus T1 greater than T3, or T2 greater than T1 plus T3, then cos theta is greater than 1, which is impossible. Cos theta greater than 1 is impossible, and equilibrium is not formed. Equilibrium is absent, therefore liquid doesn't form a drop. It spreads on the surface of liquid. For example, I will give here example, chloroform. That means chloroform doesn't form a liquid, that is drop. Whenever we pour the chloroform on this, suppose a white sheet, then it spreads, it forms a film. For that, this is the case. I hope you all understand this. Again, I will explain. You see here, T2 is equal to T1 plus T3 cos theta. Cos theta is equal to T2 minus T1 upon T3. No doubt here. Now, suppose we can have first case, T2 greater than T1, cos theta is positive, theta is acute. That means we have studied here concave surface. Okay. Now, second one, if T2 less than T1, cos theta is negative, theta is obtuse, convex. convex surface. If T2 minus T1 nearly equal to T3 cos theta equal to 1 and theta is equal to 0, plane surface for distilled water we consider here. And if T2 minus T1 greater than T3 or T2 greater than T1 plus T3 cos theta greater than 1, and it is impossible, equilibrium is not formed there, equilibrium is absent, and not drop is not formed. For example, we consider here chloroform. This is all about shape of a liquid drop. Now we will consider next article, explanation of angle of contact. Explanation of angle of contact. Explanation of angle of contact. Here, consider a liquid is in contact with the solid. Suppose I consider this is the solid, this is the solid, and liquid is in contact with this solid. Suppose this is the liquid. Now here this is the point of contact. Now whenever liquid is in contact with the solid, suppose this all is the liquid. Now we consider here, suppose this molecule is A, and suppose we consider here, suppose this is the sphere of influence of molecule A. Suppose this is molecule A. Now sphere of influence of molecule A is half in solid and 1/4 part in liquid and 1/4 part in air. Now here you see air molecules in this 1/4 part, they are less in number, therefore we neglect this adhesive force. Now we consider only two cohesive forces, we consider only two forces. Here you see, suppose AP, this is the resultant adhesive force between liquid molecule A and all solid molecules in this direction, who are these solid molecules, and AP be the resultant adhesive force. Now we consider, suppose AC, this is the resultant cohesive force. We consider here AP bar, this is the resultant adhesive force. AC is the resultant, we consider here cohesive force. Therefore behavior of molecule A depends only on these two, that is these two forces, AP bar and AC bar. And free surface of liquid is always perpendicular to the resultant of these two. Free surface of liquid is always perpendicular to the resultant of these two. Now we will consider one by one. Case 1. Suppose here you see, I will draw another example here, diagram. Suppose this is the solid, this is molecule A. Now whenever liquids which partially weights the solid, then AP is small as compared to the AC. That means here, suppose I will draw here, AP is small as compared to AC. This is AP, this is AC. Now if we consider here, AP is small as compared to the partially weights. Suppose one mistake here. AP is large as compared to AC. AP is greater than AC. I will show like this. AP is greater than AC. And suppose we draw the parallelogram. Here you see. Then resultant is AR lies in the solid and molecule A reaches in the upward direction, and so this is the liquid surface. Here you got, suppose this is the tangent, this angle is theta, and therefore theta is obtuse. Now we consider, do you understand? AP is greater than AC, therefore AR is in the solid, and therefore liquid surface is perpendicular to resultant always, and therefore molecule A moves in the upward direction. and so we get this type of theta acute. Then second case, case 2. Suppose I will draw another same example, same diagram here, same diagram, same type of diagram. 1 minute. Suppose here molecule A is here. Now here AP is less than AC. Now if we here AP, now if we obtain the parallelogram, then here this is the parallelogram, this is the resultant which is in the liquid. Now the natural tendency of the liquid is to remain its surface perpendicular to AR. Therefore this molecule A moves in the downward direction and we get here convex surface. And if we draw the angle of contact like this, then this theta is obtuse. Theta is obtuse. And case 2, we consider this is the second case, case 2. And whenever completely wets, I didn't draw here diagram, whenever it completely wets, then here AP is very much greater than AC. Therefore resultant is in this direction and liquid surface remains directly perpendicular. See here, AP is very greater and AC is very smaller, then liquid surface is plane surface. Okay, this surface is plane surface. This is the case 3. This is all about the explanation of angle of contact. I hope you all understand this. Thank you.